For centuries, one star has fascinated humanity more than almost any other in the night sky. Glowing with a deep crimson light, Betelgeuse stands apart from the colder white and blue stars surrounding it. It does not merely shine, it appears alive, flickering against the darkness like a cosmic ember. Positioned in the shoulder of Orion, Betelgeuse has guided travelers, inspired myths, and marked changing seasons for civilizations across Earth. Ancient cultures treated the heavens like a living map, and this fiery red star became one of its most recognizable landmarks. But beneath that calm glow lies extraordinary chaos. Betelgeuse is a red supergiant, one of the largest and most unstable types of stars known. In recent years, astronomers have watched it behave in ways that challenge long-standing theories about stellar evolution. The star brightens unexpectedly, then dims dramatically without warning. While variability is common among giant stars, Betelgeuse no longer follows predictable patterns. Scientists using observatories worldwide, including James Webb Space Telescope, have observed signs of violent turbulence inside the star. Massive currents of superheated plasma rise and collapse across its surface. Some of these convective regions may be so enormous that a single one could stretch across distances comparable to Earth's orbit around the Sun. Imagine gigantic bubbles of stellar fire erupting and sinking within a star hundreds of times larger than our Sun. Betelgeuse constantly swells, contracts, and reshapes itself in a restless battle between gravity and nuclear energy. To understand its scale is to understand why astronomers are captivated by it. Betelgeuse lies roughly 600 to 700 light-years from Earth and ranks among the largest stars visible to the naked eye. If it replaced the Sun at the center of our solar system, its outer atmosphere could extend beyond the orbit of Mars and possibly approach the asteroid belt. Although its surface temperature is cooler than smaller stars, giving it its red appearance, the star still releases tens of thousands of times more energy than the Sun. Its brilliance comes not from stability, but from instability. Massive stars live fast and die violently. Inside Betelgeuse, nuclear fusion has spent millions of years forging heavier elements layer by layer. But as stars approach the end of their lives, their internal structure grows increasingly unstable. The core contracts while the outer layers expand outward into space. Tremendous pressure fluctuations ripple through the star, creating irregular pulsations and eruptions. Astronomers now believe Betelgeuse may be entering one of the most turbulent periods of its existence. And that raises an extraordinary question: could humanity someday witness its death? When red supergiants exhaust the fuel sustaining their cores, gravity suddenly overwhelms them. The core collapses in an instant, triggering one of the most violent explosions in the universe, a supernova. For a brief moment, a single exploding star can outshine an entire galaxy. Current scientific models suggest Betelgeuse may still survive for tens of thousands, perhaps even hundreds of thousands, of years before that final collapse occurs. Yet its recent unpredictable behavior has sparked renewed debate among astronomers. Some wonder whether hidden processes deep inside the star are accelerating faster than expected. No one truly knows. And that uncertainty is exactly what makes Betelgeuse so compelling. If the star exploded during humanity's lifetime, it would become one of the greatest astronomical events ever witnessed. It could shine as brightly as the full moon and possibly remain visible during daylight hours. At night, it might even cast faint shadows across Earth. Fortunately, despite its enormous power, Betelgeuse is far too distant to threaten our planet. Instead, it would offer humanity something unprecedented: a front-row view of a nearby supernova observed with modern technology for the first time in history. But before jumping to dramatic conclusions, scientists are carefully studying what may truly be happening inside this unstable giant. And the answers may be even more fascinating than the explosion itself. In late 2019, astronomers around the world noticed something astonishing. Betelgeuse suddenly began fading. Over just a few months, the famous red star lost nearly 40% of its visible brightness. Even casual skywatchers could see the difference. Speculation spread rapidly across the world. Was Betelgeuse about to explode? For a moment, many believed humanity might be witnessing the beginning of a supernova. The event soon became known as the Great Dimming. As researchers investigated the phenomenon, a more complex explanation emerged. Evidence suggested that Betelgeuse had likely ejected an enormous cloud of gas and dust from its surface. As this material drifted outward, it temporarily blocked part of the star's light, making the giant appear far dimmer from Earth. Rather than signaling immediate death, the event revealed something equally important. Betelgeuse is far more dynamic and unstable than astronomers once believed. Red supergiants regularly lose mass as they age, shedding tremendous amounts of material into surrounding space. But Betelgeuse appears to do this on a colossal scale. Infrared observations from the James Webb Space Telescope revealed arcs of dust, uneven plumes, and turbulent outflows surrounding the star like expanding cosmic smoke. These structures suggest that Betelgeuse is actively reshaping the space around it. Some scientists believe giant convection cells are responsible for many of its brightness changes. Others suspect magnetic activity may influence how energy moves through the star's outer layers. There is also growing interest in how intensified mass loss could relate to the final evolutionary stages before a supernova eventually occurs. Despite all the excitement, astronomers remain cautious. A brightening or dimming red supergiant does not necessarily mean an explosion is imminent. Stars like Betelgeuse can undergo dramatic instability for thousands of years before finally collapsing. What we are observing today may simply be one chapter in a much longer process. Still, Betelgeuse offers scientists an extraordinary opportunity. Because it is relatively close to Earth, astronomers can study it in remarkable detail compared with other massive stars. Every fluctuation in brightness, every burst of dust, and every strange pulse provides clues about how giant stars evolve and die. And when stars like Betelgeuse finally explode, they do more than destroy themselves. They create the ingredients for future worlds. Supernovae scatter heavy elements such as oxygen, carbon, calcium, and iron across space. Those materials eventually become part of new stars, planets, and even living organisms. In a very real sense, the atoms inside the human body were forged long ago inside ancient exploding stars. Betelgeuse will someday contribute to that same cosmic cycle. Creation through destruction. Life emerging from collapse. That paradox sits at the heart of stellar evolution. Today, astronomers continue monitoring Betelgeuse with powerful telescopes, searching for patterns hidden within its restless behavior. Every new observation deepens the mystery. The star continues resisting simple explanations, reminding scientists that even the most familiar objects in the sky can still surprise us. Some researchers now suspect that stars may display warning signs long before exploding. If true, Betelgeuse could become the key to understanding how supernovae begin, a process humanity has never directly observed in real time. For thousands of years, people believed Betelgeuse was fixed and eternal. Now we know it is anything but still. It is unstable, evolving, and moving toward one of the most extreme transformations nature can produce. Whether that transformation happens tomorrow or tens of thousands of years from now, Betelgeuse has already changed modern astronomy. And as humanity continues watching this fiery giant burn in the shoulder of Orion, one truth becomes impossible to ignore: even the brightest stars still hold secrets.